Okay, so welcome back to the freezer to talk about charge points. So yes, and a special welcome if you're one of my members. There's a link in the description if you're interested in sort of more in-depth EV sort of information and having more in-depth chat, stuff like that. So feel free to check that out. So I did a previous video on these granny cables and just kind of checking, that things are safe and the risks that you can have with those in terms of overheating and stuff like that. We didn't really talk about whether they're safer than a properly installed charge point. So there's obviously an advantage to having a charge point on the side of your house. That's a 16 amp one. I've got a 32 amp pod point on the side of my house, so like 7 kilowatt charging. That is one of the main advantages. Obviously they charge a lot faster. So one of these sort of 3-pin granny cables, it's 10 amps. So what's that, about 2.5 kilowatts? You might lose half a kilowatt in just kind of fixed losses, so the car running coolant pumps and keeping ECUs alive and all that kind of stuff, in heat and all that kind of stuff. So you're losing a bit there, so you're only getting effectively 2 kilowatts into the battery. If you can do 3.5 miles per kilowatt, yet you're getting about 7 miles in an hour, pretty slow. Whereas one of these, you're getting more like about 30 miles for each hour of charging, which is pretty good. If you've been out for the day, you've been to work, whatever, and you're a bit low, you put it on for a couple of hours over dinner, get yourself ready, you've got a reasonable amount of charge to go out for the evening. So a lot more sort of user-friendly in that way. But are they a lot safer? Are there other advantages? So this is actually the old circuit board from my pod point. It had an issue with logging the stats. So in the app, you can kind of look at how much charge has been used and whatever. And it stopped doing that. So they came out and replaced the circuit board, which is kind of nice. So this is what's inside it. It's obviously a lot bigger than what's inside here. We can look inside here as well, because that comes off. Unfortunately, the circuit board's kind of potted. But these are the relays that turn on the this sort of positive and negative. The earth is permanently connected for safety reasons. So we can see on this one, we got relays here, we got a lot bigger relays. Interestingly, there's also space for a SIM card there as well. Mine is on the Wi-Fi, but if you don't have sort of Wi-Fi signal, they can have SIM cards fitted. This circuit board can also be used for 3-phase charging as well, because there's 2 spaces here for 2 more big relays, and I guess that's related to the single phase because there's space for 2 more little ones of those there, which is interesting. This seems to be called Sparky, this one. So there are some advantages to having a properly installed charge point, other than just it being faster. So the main advantages are in safety, really. So these 3-pin charge cables obviously work, they fulfill the function, they do the communications, the handshake with the car, and turn on the power and allow you to charge. Similar to these, but these just obviously allow the car to charge faster. I should say that these charge points are not chargers, they just provide mains to the car. The rectification into DC, the actual charging, is done inside the car, so they're not chargers, they're kind of charge points. But people kind of say, well, they're glorified relays, why would I pay for an expensive one when I can get a cheap one? Well, they do the comms, they have the relays, but they also do a couple of other things, and some of those are kind of in the install. So you'll have a new breaker installed, and that will be the correct rating and type for the car, which is very important. And there's 2 main safety features that an installed charge point will give you. So the first one is PEN fault protection. So PEN fault, protective earth neutral. So protective earth is your earth and then your neutral. So earth and neutral faults. Basically, if you were to lose the earth or neutral connection to your house, so sometimes there are different installs of electrical systems. So if you're interested in that kind of stuff, look up John Ward's videos because they're fantastic. But broadly speaking, you commonly just have a live and a neutral or live and earth coming into your house. And at your consumer unit, or at your cutout, at your meter, it is split. The earth is split between earth and neutral, and they're basically connected together. So, but you're going to say, well, that's not right, because earth and neutral are 2 different things. They're not the same. So what happens basically is the earth and neutral, which are actually connected together, so you only have 2 wires coming into your house, and then when it gets to your consumer unit, you got your live and you got your earth, and then the earth is actually split to earth and neutral. And in your consumer unit, effectively, the neutral is the path that the consumer unit expects the current to flow. So if there's current going down the live, it expects that the same amount of current to be effectively coming back, or the same amount of current to be flowing on the neutral, because you've got a circuit and current is all the same all the way around. If there is current flow on the earth, then it knows that there's a fault and it will trip the breaker. So the earth is effectively just a second neutral where there's not meant to be any current. And that's basically the difference. So that's why they can be connected to the same thing, because they're both a neutral. The only difference is your consumer unit knows that the current is meant to be on one and not on the other. And it also, the consumer units are surprisingly clever. They will also monitor the amount of current that's kind of like going down the live, and if the same amount isn't coming down the neutral, it will trip for that reason as well. So a lot of clever stuff happens in there. But yeah, pen fault protection is an additional protection with installed charge points. One of the others is DC leakage protection. So a car is obviously a DC device, it's a battery device, but a big one. And a car which has a fault, which has maybe like moisture in the air conditioning pressure or something like that, can cause leakage from the high voltage battery to the chassis of the car. And a properly installed charge point will be set up to detect that. It's called an insulation or an isolation fault. And the charge point will detect that, whereas a granny cable won't. And I've seen a few interesting faulty cars where people will say, I thought it was an issue with my charge point because the car won't charge on the charge point, it trips. But it'll charge on my granny cable. And the reason for that is actually the car's got a fault. The fault isn't bad enough potentially for the car to pick up, because cars do their own insulation testing as well. But it might be a little bit borderline, but the charge point will pick it up, or sometimes a DC rapid charger will pick it up and refuse to charge. Whereas the granny cable doesn't have that level of protection, so it will happily charge when the car's actually got a fault. So kind of interesting. So they're the kind of two main things. There are other protections, but it just really suffice it to say an installed charge point is safer than your kind of your granny cable. I always kind of find it kind of fascinating looking at these. I do a few circuit board repairs, and you start to kind of notice things. So you've got your mains in. These blow-ons are AC capacitors, and then these sort of cylindrical DC capacitors, and then that line there. So you've got to separate high voltage and low voltage. So the kind of main side is sort of over this side, and then this is the kind of command and control side. Quite interesting, really. But yeah, I'm no big Clive, that's for sure. But I've repaired a few circuit boards, and yeah, you kind of get to know their little inductors. I think get to know what's what. I think I spotted that's probably a bridge rectifier in there. So taking AC on one side and producing DC on the other side, and probably putting it through a few inductors. But yeah, it could be an isolation barrier. Need to look it up. Anyway, but yeah, that's the isolation break in the circuit board to keep the mains over this side. And the sort of low voltage over the other side. But yeah, pretty interesting. This one actually works. I'm going to keep this, so when my pod point gets out of warranty and stops working again, I'll just put this board back in, not have stats, but it will keep working. So yeah, anything else interesting, let me know. If you've had any interesting quirks with your charge points, then yeah, let me know. Alright, hope that's interesting, and I'll catch you later. Cheers.